Good evening and welcome to today's webinar on data analytics and visualization tools. Today, I am going to make you familiar with different data analytics and visualization tools like Power BI, Tableau, Apache Superset, Google Looker, Excel, SQL, and Python. So, first, let me introduce you to the world of data analytics and visualization. In the modern digital world, data has become one of the most valuable resources for individuals and organizations. Every click, transaction, and interaction generates data that holds hidden patterns and insights. However, raw data by itself is meaningless without proper analysis and interpretation, and this is where data analytics plays a crucial role in extracting knowledge and driving decisions. Data analytics refers to the systematic process of examining data sets to draw meaningful conclusions, combining statistical methods, computational tools, and domain expertise to uncover insights. Organizations use analytics to understand customer behavior, predict trends, and improve performance, while data visualization complements analytics by transforming numerical results into visual stories. Visualization tools help present data in charts, graphs, and dashboards that are easy to interpret, making them essential for data driven decision making. The data analytics process begins with data collection from multiple sources such as databases, APIs, sensors, social media, and business applications. Once collected, data is cleaned and transformed to ensure accuracy with cleaning processes, removing duplicates, correcting inconsistencies, and handling missing values. After preparation, data is explored through statistical summaries and visual inspection to identify trends, anomalies, and relationships. Analysts then apply models and algorithms to derive deeper insights using predictive models to forecast future outcomes and prescriptive models to recommend optimal actions. The results of these analyses are communicated using visualization tools which translate complex data into clear visuals like dashboards, infographics, and charts. Good visualization is not just about aesthetics, it is about understanding since humans process visuals faster than numbers, making charts powerful storytelling devices. A well designed dashboard helps executives make decisions at a glance and validate data quality by revealing inconsistencies visually. Visualization bridges the gap between technical analysts and non technical stakeholders, providing a common language for business communication. Numerous tools exist for analytics and visualization today, ranging from code based languages like Python and R to business intelligence platforms like Power BI, Tableau, and Google Looker. Open source tools such as Apache Superset and traditional ones like Excel remain popular due to accessibility and versatility. Each tool has its strengths, some specialize in exploration, others in automation or real time dashboards, but all share the same purpose to convert raw numbers into actionable intelligence. Over the past decade, analytics has evolved from simple reporting to advanced machine learning and artificial intelligence applications. Big data technologies now enable the analysis of massive data sets that were once unmanageable, while cloud platforms like AWS, Azure, and Google Cloud provide scalable infrastructure. Modern visualization tools support real time data streaming, allowing interactive dashboards where users can explore and filter insights dynamically. Data analytics tools can be classified as descriptive, diagnostic, predictive, or prescriptive, depending on whether they explain past events, diagnose causes, forecast outcomes, or suggest actions. Visualization supports all these types by making findings understandable and shareable. Industries across the world rely on analytics for competitive advantage. Finance uses its Finance uses it to detect fraud and optimize portfolios. Healthcare employs it for diagnostics and efficiency. Retail and marketing depend on it for customer analysis and personalization. Manufacturing uses predictive maintenance to reduce downtime, and governments apply analytics for policy making and resource management. Education, sports, and entertainment sectors also benefit from visualization for performance tracking and audience engagement. As organizations embrace analytics, data literacy has become a crucial skill, with universities and corporations investing in analytics education and upskilling programs. This growing emphasis has created a global demand for data analysts, scientists, and visualization experts. Collaboration between engineers, analysts, and business leaders ensures that insights translate into real world impact, making visualization a bridge between technology and decision making. Yet, analytics faces challenges such as data quality issues, integration difficulties, and privacy concerns. Ethical analytics and transparency are essential to maintain trust and accuracy, and good visualization should always clarify rather than mislead. The balance between automation and human judgment defines the reliability of analytical insights. Emerging trends such as natural language processing, augmented analytics, and collaborative dashboards are making analytics more intelligent and accessible. Cloud and mobile analytics now deliver insights anywhere, anytime, while immersive technologies like virtual and augmented reality are set to revolutionize data storytelling. As these innovations advance, the future of analytics will focus on real time intelligence, automation, and ethical insight generation. Ultimately, data analytics and visualization tools are reshaping how we understand the world. That is, they empower humans to see meaning in numbers and make smarter, faster, and more informed decisions. So, the first data analytic and visualization tool with which I am going to make you all familiar is Power BI. Power BI, developed by Microsoft, has rapidly become one of the most popular business intelligence tools worldwide. Its deep integration with the Microsoft ecosystem, including Excel, Azure, and Teams, gives it a unique advantage. Power BI offers a user friendly interface with drag and drop functionality for building dashboards. It supports connections to hundreds of data sources ranging from SQL databases to cloud services like Salesforce and Google Analytics. One of Power BI's standout features is its affordability, making enterprise analytics accessible to smaller businesses. Its natural language query feature Q&A allows users to type questions and receive instant visual answers. Power BI also supports advanced DAX, that is data analysis expressions, enabling complex calculations and measures. Organizations use Power BI for finance, marketing, operations, and HR analytics. Its mobile application allows decision makers to access dashboards anywhere, ensuring data-driven decisions on the go. Collaboration is central to Power BI with seamless integration into Microsoft Teams and SharePoint. Another strength is frequent updates. Microsoft releases new features monthly based on user feedback. Power BI also integrates with artificial intelligence services, enabling predictive analytics and anomaly detection. Its security features include row-level security and compliance with enterprise standards. Another advantage is Power BI's embedded analytics, allowing developers to integrate dashboards into custom applications. In government sector, Power BI is used for transparency and citizen engagement. In healthcare sector, it supports real-time monitoring of hospital resources. Its scalability makes it suitable for both startups and Fortune 500 companies. Power BI's community is large and active, sharing custom visualizations and best practices. A key limitation is performance with extremely large data sets, though premium versions mitigate this. Another drawback is the complexity of DAX, which requires learning for advanced use cases. However, Power BI's value for money proposition is unmatched. Its close ties with Excel make it easy for existing users to transition. Power BI also supports hybrid deployments, connecting on-premise and cloud data seamlessly. Organizations benefit from its ability to unify disparate data sources into a single source of truth. In education sector, Power BI is used to teach analytics. In education sector, Power BI is used to teach analytics skills to students. Its global adoption ensures that Power BI expertise is in high demand. With ongoing innovation, Power BI continues to expand its role in self-service and enterprise business intelligence. In conclusion, Power BI combines affordability, accessibility, and enterprise power, making it a dominant force in the business intelligence market. And after learning Power BI technology, one can apply for job roles like Power BI developer, business intelligence analyst, report developer, etc. Now, the second data analytic and visualization tool with which I am going to make you all familiar is Tableau. Tableau has long been recognized as a pioneer in the field of data visualization. Founded in 2003, it revolutionized analytics by making data accessible through visual exploration. Its drag and drop interface allows users to build dashboards without writing code. Tableau's strength lies in its ability to connect to a wide range of data sources from Excel and SQL databases to big data platforms like Hadoop. Its visualizations are highly interactive, enabling users to drill down, filter, and uncover insights quickly. Tableau Public has also become a platform for sharing visualizations with the global community. A hallmark feature of Tableau is its advanced calculated fields which allow complex logic to be applied within visualizations. Organizations use Tableau across industries. Retailers analyze sales performance, banks track compliance, and healthcare providers monitor patient outcomes. Tableau also supports geographic analysis with built-in mapping capabilities. Another strength is its ability to handle large data sets through in-memory processing. Tableau's visualization library includes bar charts, scatter plots, heat maps, and more advanced types like waterfall charts and box plots. Its storytelling feature allows users to build data driven narratives for presentations. Tableau integrates with R and Python, enabling advanced statistical modeling. Collaboration is a major advantage with Tableau Server and Tableau Online, providing centralized platforms for sharing dashboards. Its user community is one of the most active in the analytics world, sharing tutorials, templates, and best practices. Tableau also supports mobile analytics, allowing dashboards to be accessed on the go. One limitation is cost. License Licenses can be expensive for small organizations. Another drawback is the steep learning curve for advanced features. However, the trade off is unmatched flexibility and power in data visualization. Tableau continues to innovate with artificial intelligence driven features such as Ask Data, which allows natural language queries. Its acquisition by Salesforce has expanded its ecosystem, integrating with CRM data for deeper insights. Tableau Prep extends the platform into data preparation, simplifying ETL workflows. For government agencies, Tableau helps with transparency and citizen engagement. In education sector, students use Tableau to learn storytelling with data. Its global popularity ensures that Tableau skills are highly valued in the job market. Tableau dashboards often become the centerpiece of the executive executive decision making. Its flexibility allows both technical and non-technical users to uncover insights. Tableau's combination of rich visualizations, community support, and enterprise features make it a leader in the business intelligence space. In conclusion, Tableau set the standard for modern business intelligence and continues to shape how organizations turn data into actionable intelligence. And after learning Tableau technology, one can apply for job roles like Tableau developer, data visualization specialist, business analyst, etc. Now, the third data visualization, sorry, now the third data analytic and visualization tool with which I am going to make you all familiar is Apache Superset. Apache Superset is a powerful open source business intelligence tool that is gaining popularity as an alternative to commercial platforms. Developed initially at Airbnb, it is now an Apache Software Foundation project supported by a vibrant community. Superset allows users to connect to a wide variety of databases including PostgreSQL, MySQL, Presto, and big data systems like Hive and Druid. Its SQL lab provides an interactive environment for running queries and visualizing results. Superset offers a rich gallery of visualization options from standard bar and line charts to advanced heat maps, tree maps, and geospatial visualizations. Dashboards in Superset are highly customizable and can be shared across teams. One of its biggest advantage is particularly attractive for startups and academic institutions. It also scales well, capable of handling large data sets through integrations with distributed SQL engines. Superset supports role-based access control for enterprise security needs. Another benefit is its extensibility. Developers can create custom visualization plugins tailored to business requirements. Superset's architecture is cloud native, making it suitable for modern data stacks. Organizations use Superset for monitoring operations, financial analysis, and customer behavior insights. Its interface enables non technical users to create dashboards with minimal training. Collaboration features allow dashboards to be embedded in web applications or shared through links. Superset integrates smoothly with Python workflows, enabling data scientists to combine with sorry, Superset integrates smoothly with Python workflows, enabling data scientists to combine it with pandas and machine learning pipelines. A key limitation is the complexity of setup, which may require technical expertise compared to plug and play tools. Another drawback is that community support, while strong, cannot match the dedicated customer support of commercial business intelligence vendors. Still, Superset's transparency and adaptability make it a compelling choice. In government and education sector, Superset is used to publish open data dashboards for public access. In healthcare sector, it supports patient data monitoring and hospital operations. Its strong SQL-based foundation appeals to analysts who are comfortable with querying. Superset's popularity is also fueled by its compatibility with Kubernetes and Docker for scalable deployments. The active development community ensures continuous improvement and innovation. Superset aligns with the trend of organizations seeking open source alternatives to reduce costs and increase flexibility. For teams prioritizing for teams prioritizing control, customization, and scalability, Superset is an excellent option. In conclusion, Apache Superset proves that open source tools can rival commercial business intelligence platforms in power and functionality. It empowers organizations to own their analytics stack without vendor lock-in, while fostering innovation and collaboration. Superset integrates smoothly with Python workflows, enabling data scientists to combine it with pandas and machine learning pipelines. And after learning Apache Superset technology, one can apply for job roles like data engineer, business intelligence developer, open source, analytics engineer, etc. Now, the fourth data analytic and visualization tool with which I am going to make you all familiar is Google Looker. Google Looker has emerged as a modern business intelligence BI platform designed for the cloud era. Unlike traditional BI tools, Looker emphasizes a modeling layer that ensures consistent metrics across an organization. This modeling is powered by LookML, a unique language that defines data relationships and business logic. Looker integrates seamlessly with Google BigQuery and other modern cloud databases, making it highly scalable for large data sets. A standout feature of Looker is its self-service analytics. where business users can explore data without relying on IT teams. Its drag and drop interface makes it easy to generate reports and dashboards quickly. Looker also provides embedded analytics, allowing organizations to integrate dashboards directly into applications and customer portals. Collaboration is another strength. Users can share dashboards, schedule reports, and integrate with tools like Slack and Gmail. Looker's real time analytics enable decision making based on the latest data instead of stale reports. Another advantage is governance. LookML ensures that metrics like customer lifetime value or gross margin are defined consistently company wide. This avoids the common problem of multiple versions of truth seen in other tools. Looker supports advanced visualizations ranging from heat maps to geographic maps, providing flexibility in storytelling. It also supports predictive analytics through integration with machine learning platforms. Security is enterprise grade with role based access and compliance with global standards. Looker is also developer friendly, offering APIs and SDKs for custom applications. Organizations use Looker for a range of organizations use Looker for a wide range of cases. Retailers analyze supply chains, banks monitor risk exposure, and media companies track audience engagement. Its native integration with the Google Cloud ecosystem provides a significant advantage for organizations already invested in Google Cloud Platform. Looker Studio, a free companion product, extends reporting capabilities to smaller teams. The acquisition of Looker by Google has accelerated innovation and positioned it as a strong competitor to Tableau and Power BI. However, Looker's pricing can be a barrier for small businesses. Another limitation is its reliance on modern SQL databases, making it less suitable for legacy systems. Despite these, Looker's combination of scalability, governance, and ease of use makes it a sorry despite these Looker's combination of scalability, governance, and ease of use makes it a favorite in the cloud business intelligence space. Its flexibility allows both analysts and business users to gain insights at their own pace. Looker also excels in real-time customer analytics where streaming data can be visualized instantly. By combining governance with flexibility, Looker bridges the gap between IT control and business agility. In short, Google Looker redefines business intelligence for the modern cloud first organization. It empowers businesses to scale analytics, ensure consistency, and make faster decisions based on reliable data. And after learning Google Looker data analytic and visualization tool, one can apply for job roles like Looker developer, cloud analyst, analytics engineer, etc. Now, the next data analytic and visualization tool with which I am going to make you all familiar is Excel. Excel has stood the test of time as one of the most trusted tools in data analytics. It is often the first tool that professionals are introduced to when working with data. Despite being decades old, Excel continues to evolve with powerful features. Its simplicity and accessibility make it popular across industries and professions. Excel is excellent for handling small to medium sized data sets. Its grid format provides a visual way to organize data. Users can apply formulas like sum, average, and VLOOKUP to calculate metrics instantly. One of its most powerful features is the pivot table, which allows users to summarize large amounts of data dynamically. A sales manager, for example, can use pivot tables to view quarterly performance across regions. Charts and graphs in Excel bring numbers to life. Line charts, bar graphs, and pie charts are commonly used for performance monitoring. Conditional formatting is another favorite feature. It highlights trends and anomalies visually. Excel also supports data visualization to ensure accuracy when multiple users input information. Macros and Visual Basic for applications extend Excel's functionality further. Through automation, repetitive tasks like generating weekly reports can be completed in seconds. Excel integrates well with other systems, including SQL databases and APIs. This makes it versatile for importing and analyzing external data. In finance, Excel remains unmatched for budgeting, forecasting, and financial modeling. In marketing sector, it is used to track campaign performance and ROI. In HR sector, Excel supports workforce planning. In HR sector, Excel supports workforce planning and payroll analysis. One of Excel's main limitation is scalability. It struggles with data sets larger than a million rows. However, for many business problems, Excel's speed and simplicity outweigh this drawback. Another limitation is collaboration. Though cloud-based Excel in Microsoft 365 addresses this to an extent, Excel remains a powerful prototyping tool even in organizations that rely on advanced business intelligence platforms. Professionals often start analysis in Excel before moving to larger tools. Its familiarity reduces training costs, making it accessible to all levels of staff. For quick what if analysis, Excel remains unmatched. Scenario Manager and Goal Seek provide powerful forecasting capabilities. Excel is also invaluable in education, where it is used to teach fundamental data concepts. From budgeting at home to financial planning at Fortune 500 companies, Excel is everywhere. Its continued relevance proves that sometimes simplicity is the ultimate sophistication. In summary, Excel is not just a spreadsheet, it is the backbone of countless business decisions. And after learning Excel technology, one can apply for job roles like entry level analyst, reporting specialist, business support analyst, etc. Now, the next data analytic tool. Now, the next data analytic tool with which I am going to make you all familiar is SQL. SQL stands for Structured Query Language, and it has remained the cornerstone of analytics for decades. It is specifically designed for managing and querying relational databases, making it indispensable for data professionals. SQL allows users to retrieve, filter, and aggregate data from vast data sets with remarkable efficiency. For example, with just a few lines of SQL code, an analyst can find the top selling products across multiple regions. One of the multiple regions. One of the strengths of SQL lies in its universal applicability. One of the strengths of SQL lies in its universal applicability. Whether you are using MySQL, PostgreSQL, Oracle, or SQL Server, the fundamentals remain the same. This makes SQL a transferable skill across industries and platforms. SQL also supports advanced querying features such as nested queries, window functions, and stored procedures. These allow for deeper analysis like finding moving averages or ranking customers by revenue. Many organizations build complex reporting pipelines entirely around SQL. A critical advantage is that SQL is declarative, meaning users specify what they want and the database engine figures out how to get it. This simplicity allows non programmers to access and analyze data without advanced coding skills. However, for power users, SQL also provides robust optimization options like indexing and query tuning. SQL is not just about querying but also about managing data integrity. Constraints, keys, and normalization ensure accuracy and consistency of stored data. Another reason SQL is vital is its integration with visualization tools. Business intelligence platforms like Tableau, Power BI, and Superset often rely on SQL queries in the backend. Python's Pandas library even allows direct execution of SQL queries for hybrid workflows. A common use case is business reporting. HR teams might use SQL to calculate employee attrition, while finance teams calculate ROI. SQL is also central to ETL, extract, transform, load processes, where raw data is cleaned and prepared for analytics. With the rise of big data, SQL has evolved too. Platforms like Hive and Spark SQL Platforms like Hive and Spark SQL extend SQL syntax to distributed environments. This means analysts can use familiar SQL commands to analyze petabytes of data. SQL's readability is another key advantage. It resembles natural language, making it approachable. Even executives can understand a select or where clause at a glance. Despite the rise of Python and R, SQL remains irreplaceable because databases will always need structured queries. Its backward compatibility ensures that SQL knowledge gained today will be valuable for decades. In many job descriptions for data analysts, in many job descriptions for data analysts, SQL is listed as a must-have skill. In short, SQL is the language of data itself. From startups to Fortune 500 companies, SQL is used daily to answer critical business questions. It is a bridge between raw data storage and meaningful analysis. Consider an e-commerce company. SQL queries can reveal not only who the top buyers are, but also when they are most active. This insight can shape marketing campaigns and product launches. SQL is also critical in compliance, where accurate reporting is required for audits. For example, banks use SQL to produce daily financial reports to meet regulatory standards. The sheer stability and maturity of SQL make it a trusted companion in the analytics journey. Thus, SQL is more than just a language, it is the foundation of the modern data ecosystem. And after learning SQL technology, one can apply for job roles like SQL developer, data analyst, database engineer, extract, transform, and load developer, etc. Now, the last data analytic and visualization tool with which I am going to make you all familiar is Python. Python has become the Swiss Army knife of data analytics and visualization. It is widely adopted because of its simplicity, readability, and vast ecosystem of libraries. With libraries like Pandas, analysts can clean, manipulate, and aggregate data efficiently. Visualization libraries such as Matplotlib and Seaborn provide flexible ways to create charts and graphs. Plotly and Bokeh add interactivity, allowing dashboards to be shared with non-technical users. Python integrates seamlessly with machine learning libraries like scikit-learn and TensorFlow, bridging the gap between analytics and artificial intelligence. Another drop, sorry, Another advantage of Python is automation. Scripts can handle repetitive tasks like generating weekly reports or scraping data from websites. Jupyter notebooks have revolutionized how analysts work by combining code, visualization, and narrative text in a single document. Python's integration with SQL APIs and big data platforms makes it a universal tool for modern workflows. In finance sector, Python powers risk models and algorithmic trading systems. In healthcare sector, it is used for patient analytics and predictive diagnosis. In marketing, Python enables customer segmentation and churn prediction. Its community driven growth ensures a constant flow of new tools and improvements. For example, libraries like Altair simplify the creation of declarative charts with minimal code. Python also supports advanced visualizations like heat maps, network graphs, and geographic maps. Its open source nature reduces costs for organizations while providing cutting edge capabilities. Python is also favored in academia, where students learn data concepts through real world data sets. Another strength is reproducibility. Python scripts can be versioned, shared, and scaled easily. Frameworks like Dash and Streamlit turn Python scripts into interactive web applications for analytics. This allows teams to build lightweight dashboards without investing in enterprise business intelligence software. Python's versatility extends to cloud computing, where Amazon Web Services, Azure, and Google Cloud Platform offer native Python integrations. One challenge is performance with extremely large data sets, though libraries like Dask mitigate this. Python also relies on programming knowledge, which can be a barrier for some business. Python also relies Python also relies on programming knowledge, which can be a barrier for some business users. However, the flexibility and power make it the go-to tool for data scientists and analysts alike. Unlike graphical user interface driven tools, Python provides complete control over the analysis process. It is also a favorite in data engineering for building ETL pipelines. In journalism, Python helps creating compelling visual stories with open data. The language's role in open science promotes transparency and accessibility of research. With its global popularity, Python skills are highly valued in the job market. Whether building a quick chart or a full fledged analytics application, Python delivers. It empowers individuals and teams to unlock insights from data in innovative ways. In short, Python is not just a programming language, it is the backbone of modern analytics workflows. It connects raw data, statistical modeling, and interactive visualization into a unified ecosystem. Its constant evolution ensures that Python will remain a dominant force in data visualization for years to come. And after learning Python technology, one can apply for job roles like data scientist, ML engineer, automation analyst, Python developer, etc. Tools working together. Real world data workflows use a combination of tools: SQL for querying, Python for cleaning and modeling, Tableau and Power BI for visualization, Excel for summaries, Superset or Looker for embedding or engineering specific dashboards. Learning path is begin with Excel, learning path is begin with Excel and SQL to understand data structure and querying, then move to Power BI or Tableau for dashboard and reporting skills. After that, learn Python for automation, deeper analysis, and predictive modeling. Then explore Looker and Superset for advanced modeling and cloud native or real time analytics. So, finally, I would like to conclude by saying data analytics and visualization tools have become indispensable in the digital age, transforming how organizations interpret information, make decisions, and create value. As the volume of data continues to grow exponentially, these tools provide the capability to transform raw, unstructured information into meaningful insights that support strategic thinking. They empower decision makers to move beyond intuition and rely on evidence based strategies grounded in facts and patterns revealed by data. Over time, analytics has evolved from simple descriptive reporting to predictive and prescriptive modeling, enabling organizations not only to understand what happened but also why it happened and what is likely to happen next. Visualization complements this analytical depth by translating complex quantitative information into human understandable visuals that simplify communication and insight discovery. Together, analytics and visualization have bridged the gap between data professionals and business leaders, creating a unified language of data across industries. The impact of these tools is visible in every sector, from finance and healthcare to marketing, logistics, and public administration. They have redefined how companies measure performance, allocate resources, and interact with customers. Moreover, the democratization, moreover, moreover, the democratizi- Moreover, the democratization of analytics through user-friendly tools like Power BI, Tableau, and Google Looker has enabled professionals from non-technical backgrounds to explore and understand data without extensive programming skills. Programming languages like Python and R continue to serve as the foundation for deeper statistical and machine learning analysis, providing unparalleled flexibility and control. The rise of open source platforms and cloud based solutions has made analytics more accessible, scalable, and collaborative than ever before. Modern tools now allow real time streaming Modern tools now allow real-time data streaming and live dashboards, ensuring that decisions are made on the most current information available. This shift towards immediacy has transformed analytics from a retrospective process into a proactive capability. Organizations no longer wait for monthly reports, they monitor business health minute by minute. Visualization tools are equally critical in storytelling as they help stakeholders see relationships, trends, and anomalies that numbers alone cannot reveal. If effective visualization brings clarity to complexity, transforming large data sets into narratives that inform and persuade. At the same time, the growing sophistication of analytics introduces challenges related to data quality, privacy, and ethics. Poor quality data can lead to flawed insights, while misuse or misinterpretation of visualizations can distort understanding. Hence, responsible data governance, ethical practices, and transparency are essential components of modern analytics. The best analysts combine technical expertise with ethical awareness and critical thinking to ensure that insights lead to fair and beneficial outcomes. As technology advances, automation and artificial intelligence continue to expand the boundaries of what analytics can achieve. Machine learning algorithms now detect patterns invisible to the human eye, while AI driven visualization platforms automatically generate insights and highlight anomalies. The integration of natural language processing allows users to interact with data conversationally, reducing the learning curve for business users. Cloud computing has enabled global collaboration on shared datasets, while mobile analytics ensures that insights are available anytime, anywhere. These developments are reshaping the speed and scale of decision making in organizations worldwide. However, as tools become more powerful, However, as tools become more powerful, the human role in interpreting results remains vital. Analytics cannot replace human judgment, it enhances it. The real value lies not only in collecting data, but in asking the right questions and applying contextual understanding to interpret answers. In this sense, analytics is as much as an art as it is a science. Visualization extends this art by making data not just informative but engaging and persuasive. The future of analytics will likely see greater integration between visualization, automation, and predictive intelligence. Augmented analytics will enable systems to recommend actions automatically, while immersive technologies such as virtual and augmented reality may revolutionize how we interact with data. Organizations that embrace Organizations that embrace these technologies responsibly will maintain a competitive advantage and foster innovation. As industries continue to digitalize, data analytics will remain the foundation of transformation and sustainability. It will drive decisions. It will drive smarter decisions in business, government, education, and society as a whole. The continued evolution of visualization tools will ensure that data remains accessible and understandable to everyone, regardless of technical background. Education systems are already adapting to this reality, preparing the next generation of professionals to think critically with data. Collaboration across disciplines combining technical, managerial, and creative skills will become the hallmark of successful analytics teams. Ultimately, data analytics and visualization tools are not merely technological aids, they are catalysts for innovation, transparency, and informed decision making in a data centric world. They enable organizations to convert uncertainty into opportunity and information into intelligence. The real power of these tools lies in their ability to humanize data, to make it visible, meaningful, and actionable. As we move further into an age driven by artificial intelligence and automation, the synergy between data analytics and visualization will continue to shape how humanity understands its world, solves its challenges, and envisions its future. So, I would like to conclude by saying that no single tool is sufficient. Combine strengths SQL plus Python plus visualization. Build real world dashboards from open data or your company data. Then share your work publicly on platforms like GitHub and LinkedIn to build credibility. And last but not the least, aim to be a storyteller with data, not just a number cruncher. So that's all for today. Thank you for listening to me patiently. Let's meet in the next session.